Welcome to cs112 inventory session. So this is week 13. Yeah, so for week 13. My name is Moshin and I'll be your inventor for cs112. Okay. So since there's nothing else, so you will be doing this recording later. So let's move on. Right. So today our focus will be on linked list. Right. So linked list, there are many types. So we have single linked list, we have doubly linked list, and we have a circular linked list. So for now, let's focus on a single linked list, right? So linked list is like an array. You use it to store data. Now the difference between a linked list and an array is that in a linked list, so first look at an array because you know about an array. So in an array, you have data stored side by side in sequential order, right? So for example, if you create an array of size 5, so this will be created. It will be index 0, 1, 2, 3, 4, right? Now, so this is how our array is stored in memory, right? But if you create a linked list, you create one node, then you have to connect that particular node to another node, right? So it's a single, so there's one next. So this is the next part. And the data, you can have a data of any data type. For our example, we have data type of integer. So you can put 1 there, 2 there, and to connect this to another node, you can use the pointer to connect. Then it will be 3 here. And it can connect to another node, so 4, right? And this can connect to another node. So this will be 5. And the last one you can point it to null. Okay. So now you can see the difference between an array and a linked list, right? So in an array, data is arranged side by side in sequential order in the memory, whereas in a linked list, there are nodes, which can be at any place in the memory, and they are all connected through pointers. Okay, and so in an array, since data is stored side by side, it is easy to access all the elements. And in a linked list, it will take a bit more time than an array to access the elements, right? And so the advantages of a linked list. So as you can see, you can change the size, right? In an array, once you create the size 5, you cannot change it. But in a linked list, you can just create a new node here, and you can insert another value 6, and the next of that one, then you can make it null. So linked lists are dynamic. You can change the size. That's why it is sometimes more important, better than an array, right? So how to implement a linked list using a structure? So you have a struct, you give it a name. This name can be anything you want, and then you have two things. The data you want to store in the linked list, the type of data. So in our case, it is type integer. So it's 1, 2, 3, 4, and you need a pointer to point to the next location, right? So that pointer points to the next node where the linked list. So it will keep on pointing to each node, and finally your linked list will be created, right? So now how do we? So this is a structure. It ends with a semicolon. How do we create a linked list in the main function, right? So it's someone like this. So you have to create a object of that node. So you make it node. Let's create it to a pointer. Node pointer n equals to new node, right? Now what this does, it will create a new node like this. So in this part, node pointer n, we have a pointer n, and it points to this new node. So this is a pointer, and it points to the location of this new node. And then you can store the data there. So since there are different pointers, you just remember access operator. So it will be n data equals to 3, for example. So now what will happen is that 3 will be stored here. Okay, so this was a brief introduction on a singly linked list, right? Now let's do this simple exercise. So we have to store numbers from 1 to 10 in a linked list, right? So we will be using this linked list, and let's see. So this is our main function. Right? We have to store the numbers from 1 to 10. Right? So the first thing we do is create our pointer. Pointer and equals to no, and let's create a new one as well. Right? So if we store the numbers from 1 to 10, we can have a simple for loop. So for int I equals 1, and then I is less than equals to 10, I plus plus. Right? And in here, so we want to store the value of 1 there. So n dash data, that location is make it the value for I. So as I increment the data, so there will also increment it, right? So right, that's the first part. Then after this, what happens? Right? So when you create new node, what happens? Data pointer n that points to a new node. Then you are storing the data 1 here, right? What the next thing you want to do is you want to make n that next equals new node, right? So the place where this is going to, you want to create a new node there, right? Yeah. So that equals new node. Yeah, that, and now you want to make this pointer going from here to here, right? So then what you do is n equals n x, right? So the result is 2, and the next part will result in 2, and x is going to n. After that, yes, that's all. And in the end, you can make n equals to none, right? And so we can make n less than equals to none, right? n less equals to none. So if you're going to access the entire list, you need to know where to shop. We will learn why this is important more when we are printing the linked list, right? Because we won't know how many elements are there, so we can have a condition is till the next of the n is not null. Okay, right. Okay, so we will look at a simple example to show how lists work. Okay, so we have 3 nodes, right? For now, assume these 2 nodes are not created. So we have created this node, we have put some data there, right? And now, and we will have a pointer, for example, P, that points to this location. And there is always a pointer S that we should make it point to the first node, right? It should the head should always point to the first location in the linked list, right? Now you want to create a new node and put some data there. So we have to, where next of this one is pointing to, we create a new node. So the new node is created. Now you want to make this pointer point there so that you can change the data. So make it point here, and then you can change the data to 6, right? You can do it without changing this location, but you'll have to do like p dash next equals 6, and then it will be p dash next equals to 7, for example, right? So the same thing you do here. We'll sit to the next one, point to the next one, make this point to this node, and then you can invoke change the data there, for example 7, and at the end you can make it null, right? So that's how lists work, right? So we have to write a code to iterate through a linked list, right? So let's do it using a for loop. We can have for. We have a node pointer, for example we have r, right? So it's just a pointer that should start with pointing to the head. So next r, while the next object is not equals to null, then we point to the next one, r dash next, right? And then you can do the things you want here. So for example, if you want to print the data, you can see out the statement. So we can see out r dash data. If you want to do any other thing, you can just iterate and do it, right? Okay, now we will learn about the difference between a singly and a doubly linked list. So as we learned in a singly linked list, we have just one pointer that points to the next location in the memory. The difference in a doubly linked list is, right, that it's also a pointer previous that points to the previous location, previous node, right? And the implementation part, so here we will have another pointer node. So here we will have another pointer for a doubly linked list, which will be node pointer previous, right? So that's a major difference between a singly and a doubly linked list. So in a doubly linked list we can iterate back and forth, but in a singly linked list we can only iterate forward, right? Right, so let's write an implementation for a doubly linked list. So yeah, so we can have our struct, we can name it node, and then we have our implementation. So we have our int data, node pointer to the next, right? And then we have another node pointer previous. Yeah. So that is how the implementation different for our doubly list, right? Okay, right. Yeah. So all the questions were supposed to be done by the students, but since no attendance, yeah, so we finished early. So yeah, if you have any questions, you can always email me here, right? And so that's the end of our session, right? Thank you.